Hi, welcome to the Calculus 1 lecture series. And in this video, we are doing the chapter 4 practice test. This is our second video on the chapter 4 practice test. And this unit will cover is the application of the differentiations. Okay, let's go ahead, go to our practice test and go ahead and get started, okay? So for the video number 1, we did for the graphing part, so to, how to graph the function based on the, some guidelines we try to follow here. Okay, so now the part 2 of the test is the test more like the concept type of the problems. And so let's take a look. Let's go ahead and get started here. Okay. And so the first things here we said, what is the graph of f prime 2 greater than 0 and f double prime 2 less than 0? Okay, so for the f prime 2 greater than 0, that means at the 2's here, right? We have a positive slope, and then the double prime 2 less than 0. That means in there we have a concavity down. So if you look here, this is the 2's here, right? So because f double prime 2 less than 0, so probably this is the one will be the, okay, so in here, we have a positive slope of the tangent line. And so here, let me erase this, right? So here, at the 2 here, we have like the slope of the tangent line is positive. And also, at the 2 is kind of a concave down. So I think the answer is B here. So if you take a look at the others here, for these ones here, right, it's not, so even at the 2, the tangent line slope is positive, but then this is bending up. So this is concave up. So it's not the f double prime 2 is less than 0. So for here is this, if you take the tangent line at the 2 here, you find out that this is negative. So did not satisfy the first condition. So for here, at the 2 here, you find out that you have what? You have a vertical tangents, right? So vertical tangent and the tangent, the slope not even exists. It's there. All right. So that's why I think the problems here, the best answers here will be B's here. Okay, now let's take a look at the second ones here. So when the x equal to approach to 0, okay, so when the x approach to 0, so the first thing is here, let's say, okay, when x approach to 0, what happened to here? The 7x approach to 0, right? Then tangent 5x approach to 0, tangent 0 approach to 0. So you have a 0 over 0. Then we know the 0 over 0 is indeterminate. So we need to use the what rule? L'Hopital's rules, right? So let's take a look. What is the L'Hopital's rule teach us? So when the x approach to 0, that means you take the derivative of the top. So 7x, you become 7. Then tangent 5x, what do we have? Tangent, we have is the second square of 5x. And then don't forget what you need to do here. This is the chain rules, right? So you need to times 5 here. Now you put the x equal to 0. So the 7 has no x, so it's 7. Then the second square, 0, second square is a cosine, 1 over cosine squared. Cosine 0 is 1. So here, this is 5, right? So it's because this numbers here, the second, this one here is approach to 1 when the x approach to 0, right? So the answer will be 7 over 5 here. Okay. Now let's take a look at number 3 here. So let's say in which of the following intervals here, I'm going to have a solution here. What's that mean? Like when I have a solution, that means, if you move the, this one over, so if you say this will be the x4's plus x minus 3, right? So if you say this is f of x here, all right? So this one, that means when this is equal to 0, right? Because when you move over here, this will be here. This is x4 plus x minus 3 equal to 0. When we mean the solution, that means what is the, x will satisfy. This is 0. Okay, so now, by using, the mean value series here, right? So let's take a look here. So because this is a polynomial, so let's take a look first. If you put it for this ones here, we just need to do the, try and the arrows here, right? Okay, so now here, let's take a look for first these ones here. If you have f of -1, what is f of -1 here? So it's -1 to the 4th, right? So it's 1 plus -1 minus 3. So this is equal to what? This is -3. So this is less than 0, right? So now let's take a look at f of 0s here. So f of 0, that means is 0 plus 0 minus 3. So what is that? Is -3 also, right? So this one's here is less than 0. So let me kind of, so this is when the x equal to -1 and x equal to 0, both of them is equal to the negative values, right? So I cannot guarantee, there is a solution between the -1 and the 0. Okay, now let's take a look at the f of 1s here, right? So if you take f of the 1s here, f of the 1, so will be 1 to the 4th is 1 plus 1 and minus 3. And this is -1. So f of 1 is less than 0. So this is less than 0. So that's why I know in here, right? So from the -1 to 0, they end up at the both negative. So I don't know it will passing through the, the x-axis. So this one, probably I don't have a solution. Then from 0 to 1, also they from the, from negative to negative. So I don't know, this will have a solution. So let's continue here, right? So now if you say f of 2 here, so f of 2s, right? So 2 to the 4th is what? 16 plus 2 minus 3. So this will be 18 minus 3. So it's 15. So this is greater than 0. All right. So let me color it. So this is greater than 0. So what is that means? Tell me. So it tells me like here, right? So from the 2 to 3, right? So from the 2 to 3, and my f functions here, right? My f function is somewhere here. I don't know the exactly, so my f function is -1, right? So this is the -1. And then because this is polynomial, it's going to be continuous. I don't know what it's going to do, but when they come to the 3, they reach the value of the 15. So you travel from negative value to the positive value because this is continuous and differentiable. So they have to what? They have to passing the x-axis. That means the y equal to 0. So this will be the solution. So I can guarantee from 1 to 2, this one going to have a solutions here. Okay, so you say, okay, let's take a look at others to see how is that. So it's 2 to 3, right? 2 to 3. So 1 to 2. I'm sorry. So this is 1 to 2, right? 1 is the negative, 2 is positive. Okay, now from 2 to 3, let's take a look at f of the 3. F of the 3, so it's 3 to the 4th power plus 3 minus 3. So what do we have here? We have 81, right? So what is 81? 81 is greater than 0. greater than 0. So the sign did not change. So from 2 to 3, from 2, so from, I'm sorry, here, I graphed it wrong here. So this one should be 1 to 2, so where I go. Okay, so I need to be very careful there. So this is 1 to 2, right? So if 1 is negative, 2 is positive, so they have to touch the x-axis. But the 2 to 3, so but in here, for the here, 2 to 3, so it doesn't have to go through the x-axis, right? Because then if the function continues, right? So they can do like this. Then when the f of x of the 3, you know, you don't have to pass in the x-axis. So I cannot guarantee I have a what? I have a solution. Okay, so now let's do the last one, f of the 4 here. F of the 4, right? So it will be 4 to the 4th power plus 4 minus 1. So 4 to the 4th power is 256. Okay, so it will be 259. So this number still is greater than 0, right? So now from 3 to 4, I do not see a sign changes here. So that's why I cannot guarantee to have a what? To have a solution. But from here to here, right? So from 1 to 2, I did see a sign change because this is a continuous function. It has to pass here. All right. Okay, now let's take a look at problem number 4 here. They said the number C satisfies the mean value series. So what is the mean value series? You know, the mean value series, like we say, you know, if you have like some functions here, right? So if you have some function, this is f of A, this is f of B, right? So we said if you connect these two, you know, if you connect these two, right? So these 2 points, you will get a line, and the slope of this line will be f of B minus f of A over B minus A. So the mean value series tell you, say, hey, you're going to find in between A and B, you're going to find C where, you know, the tangent line to this C will have the same slope. That's what we talk about is the mean value series here. Okay, so now let's take a look here. So the f of the x cubed, right? So between 4, so I know the f of the 4, okay, so the f of the 4 minus, okay, so this is f of the 4 minus f of the 1 to the 4 minus 1s, right? So the 4 minus 1, well, so what's going on here? So okay, so back, okay, so a while ago, I think the internet has some problems here. So this is a 4 minus 1. Okay, so the 4 minus 1, so it's 4 to the, so this is a 4 to the cube minus 1 to the cube, 4 minus 1. So this is a 64, 64 minus 1 is 63. 4 minus 1 is 3 is equal to 21 here. All right. Then they say you're going to have a tangent line. So what does a tangent line mean? Tangent line means it's derivatives, right? So you got the 3x squared. So they say they're going to have a tangent line. You can be able to find the C value here. We'll have the same slope here. That means I'm going to have the same slope here. So 21 here, right? So that's why I got the x squared is equal to what? Equal to the 7th, right? So x could be equal to the square root of the 7 or negative square root of the 7. So take a look, because my regions here is 1 and the 4 here. So I know x cannot be the negative square root of the 7. So here be the square root of the 7. So the answer here is 8 here. Okay. Now let's take a look here. The number 5. the number 5 here is said f is a critical number, and for f and f of x is greater than 0, for x is less than 4. So let's put this is 4. So this is greater than 0, and this is f prime x, right? And this is less than 0. So we know greater than 0, that means increasing and decreasing, right? So this is your f function is increasing. So what do they say here? So we have a local max, right? So it will be local max at equal to 4. So let's see why the B is not right. They say have a local mean, so it's not because it's go up and go down. And the 4 is either local max or local mean, no. And f is absolute max. I'm not sure it's absolute max because I don't know, what is the function or what is the domains here. So absolutely it's not the absolute mean, and there is either local max or no. So we know the 4 is a local max here. All right, so now let's take a look at these ones here. So when the x approach to 0, and so what happened here? So the sign, so this will be 0 minus 0. So this will be equal to 0. What is here? This is zeros, right? So we say, oh, okay. So then what rules we need to use? We need to use the whole Petals rule. So let's try again. So the x approach to 0. Then I just take the derivative at top and the bottom. So this is 3. Then sine 7x is what? It's a cosine 7x. Ha, don't forget the chain rule times 7, right? Then minus what? 4x, correct? Okay, so now in here, now you put the 0 in again, so this will become 0. So what is a cosine? 7 times 0 is 1, right? So it's 7 times 1. So what is the final answers here? It's 7 over 3, right? Okay, so 7 over 3. So what is the answer? Is is here, okay? All right, so the number 7. So we said which one is the Rollie series? So remember the Rollie series tell us is like in here. If f is like this is A and B, and so if this is continuous and the key things for the Rollies here, that means in here FA equal to the FB, then we said you can find at least 1 point C, you will have what? The slope equal to 0, right? Okay, let's take a look which one is not. Okay, f has to be continuous, that's right, because you cannot have discrete, and this is a key condition, right? FA has to be equal to FB, so this 2 point has to be equal. F greater than 0 for all the x in the AB. We don't have to, because in here, you still can have the Rollie series like this, right? Let me give you another graph here. You can have a Rollie series like go like a ding, 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 like that, right? So it doesn't have to be all greater than 0. So this is not a condition. Then the F is differentiable, that's true, right? Because that means I can find the slope of tangent line equal to 0. So C is not the required condition for the Rollie series here. Okay, now let's take a look at the problem number 8 here. Okay, so for the number 8, I'm going to find the limits here. So it's 1 plus x to the negative 2x. So when the x approach to the 0, so let's see what is this one's going to be. When x approach to 0, right? That means this 1 plus, so it will be approach to 1 to the what? Negative what? Infinity. So we know 1 to the infinity is indeterminate form. So I don't know what is the limits. So what do we need to do? How we need to by using the log forms, right? So we say y let's try to say y is equal to the 1 plus x negative 2 to the what? 2 to the x, right? And then we set a natural log of y, so it just be negative 2 to the x, natural log 1 plus x. Okay, so now let's take a look one more time. When x approach to 0, so what is this number going to approach to? When x approach to 0, this one approach to 0, this one approach to 0. So my whole thing approach to 0 over 0. And we said, oh, that's pretty good. 0 over 0, I know I can use the local Petals rule. So I would say limit x approach to 0, take the derivative. So x take the derivative is 1. Natural log 1 plus x takes the derivatives is 1 over 1 plus x. Don't forget, I still have a negative 2 in front, right? Now you put the x approach to 0. What do you have? You have a negative 2. Correct? Because these ones here, when x approach to 0, these are going to approach to 1, right? So I have a negative 2. But be careful, negative 2 is y, natural log y. So what is the y? You need to e back, right? So it's so the limit here, it will be what? The limit will be e to the negative 2 powers here. All right, so now let's take a look. So what is the e to the negative 2? So that means this one here is 1 over e to the square, correct? So I know it's not this one, not this one, not this one. And then here, not this one. This one looks similar, but they have a negative sign here, so it's not this one. So what is here? Is here, should be 1 over e to the what? 1 over e to the square here. Okay, now let's take a look at the problem number 9 here. Okay, so where we're going to have a local max, all right? So let's take a look here, right? So the local max here. So I know that here definitely, so this one is a local max, right? So this is x equal to 2. What is this one? This is a local means, right? So this is the green one is a local mean. So this is a local mean here. Okay, so the next one here is this one here. This is a local max? Well, and no, this is not local max because for this province here, the x is the x values here is empty, right? So the only local max is where is c is equal to x equal to 2. When the x equal to 4, it's not a local max, and it is a local mean, but it's not a local max here. All right. Okay, so number 10, the truth and false here. Okay, so the truth and false, let's see here. All the hypotheses for the mean value theory hold for this one. So it's true or false? This one is false. So which one is false? Because we said the mean value theory, there has to be what? Continuous. Right, this is the first one. Then the next ones here, we say the FA, not equal to FB. So this one is true. And then the most important one is what? F is what? Differentiable. Right? So we know this is absolute value function. Absolute value function is not differentiable at the vertex point here. So absolute value x is here, this sharp point will be x equal to 0. It's between here, right? So, it's not differentiable. So it's false here. Okay, so part B, let's say, if a function is not increase, then it is a decrease. It's what? It's a false, not necessary. So if in these intervals here, right, like in the AB, I can have a flat functions, right? So this is a constant function. So this function is not increase, but it's not decrease neither. Okay. So then let's take a look at the last one. See here, they said f of x is increasing in the 0, 1. Let's see here. So what is my f prime x? So my f prime x is ax minus a. So let's set x minus a. Let's set it equal to 0, x equal to 1. That means I have here, right? So for everything, for all the number, if it is smaller than the 1, let's see what happens. Smaller than 1, I'm going to have a negative value, correct? Smaller, if greater than 1, I'm going to have a what? Smaller than 1, right? Okay, negative number, right? So greater than 1, I'm going to have a positive numbers here. So I know the smaller than 1, this is decreasing, this is increasing. So the interval 0, 1 is supposed to be what? Decreasing. So this is a false here. Okay. Okay, number 11. So this is kind of a good problem, right? So let's take a look. Let's say sometime, always, never. Okay, so let's say this one is here. Be careful, right? So let's say if C is a critical number, then f prime C has to be equal to 0. Is that true? Is the answer is sometime. Why is sometime? Because we said the critical number has two situations, right? First situation is f prime x equal to 0. You solve for that. Or is f prime x does not exist. So sometimes it will be, but it doesn't always guarantee, right? Okay, so then let's say if f prime c equal to 0, then c is a critical number. Is this true? Sometimes, always, never? This is always true because that's how do we define the critical number. It's a two situation, f prime x equal to 0, right? Okay, so number C is here is true or false. It said if f prime c exists and f has local mean, then f prime c will be equal to 0. If this is exist and f has local mean at c, is true? Yes, because it has to have like a turning point here, right? Because this exists. Okay, part D is here. Let's say the absolute extrema of a continuous function close on a closed interval is always exist. Is true or false? The absolute extrema of a continuous function. So what is that? Always exist. This is what? This is true, right? Because it's in a closed interval here, A and B, see here, right? Because it's a continuous, so it has to have an absolute max and has to have the absolute mins here. Okay, so this is true. Okay, so this is our second video. We talk about the concept problems here. This will be a good place to stop. Okay, and let's stop here and we work on the remaining on the next video. Okay, nice talk to you.